Hello, everybody. I am going to be sharing with you some of the features of the PSPP software. So, the PSPP software is actually open source, which means it is free and available to anyone who would like to use it. And it is a software that is meant to analyze quantitative data. It is an acceptable replacement to the far more expensive SPSS software. Um, we will be utilizing PSPP instead of SPSS for the quantitative analysis portion of this module. Um, when it comes to what PSPP can do, it is not as sophisticated as SPSS, but it does have some capabilities. And definitely for basic data analysis, which is what we will be covering in this module, it is definitely sufficient. So, as I mentioned before, PSPP requires that you utilize quantitative data. So if you in this what we call the data view of this data set, what you will notice is that all the data is numerical in nature, and so we're dealing with, as we say, quantitative data. If it was textual data, then the software would not be able to do any analysis on it. All right, so let's just discuss some of the features of this software. Firstly, as I just toggled, you realize there are two views in the software. You have a data view, which looks quite similar to a spreadsheet. Each new variable or each variable is arranged in a column, whereas each case is arranged in a row. And a case is actually a single person's response to the survey items. So if a questionnaire has 28 questions, then there will be 28 columns. If a questionnaire, if in your survey you sampled 100 people, then your data file will have 100 columns for the 28 columns for the 28 questions, but 100 rows for the 100 cases or people who participated in your survey. The variable view is really and truly for you, the user of the software. The variable view provides you with more information on the variables themselves. The truth is, the software doesn't really need to know all of this in order to run any analysis. Once it has data, it will be able to compute pretty much whatever procedure you ask it for. However, in order for you to make sense of the data that is there, you do need to know, for example, the name of the variable. You also need to know, for example, what those names stand for. So, for example, I think this particular file is exemplifying why we call these the variable labels. This exemplifies why variable labels are needed, because if you look here, you'll notice that the variable name is A3. But what does A3 stand for? What is measured? What is captured in A3? You really do need to go to the variable label to see that. Now, it is possible to give the variables more names that more closely reflect what is being measured, but that is not always the case, especially as there are certain requirements when it comes to actually putting in variable names. And so because of that, you might have to condense your variable names. You might have to condense your variable names. You might have to actually kind of put the words together without any spaces, because the software doesn't actually allow spaces in the variable names. And so because of that, we tend to rely on the label, the variable label, which is this column here, to actually give us information about the variable that is being measured. Then you have the value labels column. And this column is extremely important, because what it does is that it tells you what each value stands for. So, for example, when you go to variable A2 in your data view, right, you will find, trying to see. All right. So if you look at variable A2, you'll notice that when you look at it, you'll see that there some person's response was 0, some person's response was 1, but you have no idea what those numbers actually stand for, right? And because of that, you are not able to interpret your variable properly. But in the variable view, you have what are called value labels, and what it does is that it provides detail as to what the values slash numbers actually represent. So if you look at the value labels for this variable A2, you can see that 0 is female and 1 is male. And that would be very, very important to know, for example, right? You also have this column here called missing values. And what this column actually represents is any variable or variables that were captured, or responses that were captured, that are not useful for your data analysis. So for example, you might find that let's see if I can find a variable that is measured. Okay, so for example, here, variable A6, it asks about residents at college, asking people like what is their living situation. And so you had options like single sex residence or dorm, co-ed, other university housing, frat or sorority house, off-campus house or apartment. And then there was 6, other. What does other capture? I'm not quite sure. So it is possible that for purposes of the analysis, I might want to exclude anybody who indicated other as their response, right? And so that would then become my missing value. So what I'm telling the software to do is that when you are analyzing the data, please ignore any respondent that gave the response other or 6. That person should not be part of my data analysis. So this is what the missing values column is really about. And you can have multiple missing values, and it is actually a very important part of what we call cleaning our data, and I will get into that in a little bit. Another column here in the data set that you, or in the variable view, that is quite useful is the measure column, and this is now the where it speaks to the level of measurement. And you guys would have learned about measurement in our measurement lecture, and you would recall that there are 4 measurement levels: nominal, ordinal, interval, and ratio. In SPSS, however, we only have 3: nominal, ordinal, and scale, and that is because interval and ratio data are considered to be scale and are treated the same. And just to recap, nominal level variables are pretty much used to for classification or identification purposes. So for example, a variable like gender, right? When you look at the variable gender and somebody says, what is your gender? And they say they are female or male. What has happened is that in order to measure the variable quantitatively, you have to actually make each response be equal to a number. And so the numeral 0 is placed in the space where anybody says female. Meanwhile, the numeral 1 is placed in the space where anyone says male. And so because of that, we are able to actually know what those stand for. However, when it comes to statistical operations, there are limitations to what we can do with a nominal level variable. So for example, because these numbers are there, that doesn't mean you can add them up. Because in this instance, if I add 1 plus 0 and I get 1, what does that tell me about this variable? What does it tell me? Nothing at all. So the numbers themselves when you measure variables at the nominal level do not actually stand for what numbers really stand for. Those numbers have no true meaning. They're just there as space holders. And as a result of that, all we can do to those variables are counting operations. So we can say how many, we can say what percentage, and we can also talk about which number appears most frequently. However, we cannot compute averages and stuff like that, because again, it's not or even a median, it is not useful. And in terms of advanced statistical procedures, there are limitations as to what advanced statistical procedures we can conduct using or with nominal variables. All right, and so you can see here that this variable is not identified as nominal. Now, the next measurement level is considered to be ordinal, and an ordinal variable performs what we call a ranking function, and so it is arranging things in a particular order or sequence. So for example, we talk about first, second, third in a race or in class. It tells you who had the highest average, who had the second highest average, who had the third highest average. However, one of the things about ordinal variable is that the distance between scale points is undefined. What that means is that the distance between first and second is not uniform. So for example, I can come first in my class with an average of 99.8. And the person who comes second has an average of 99.75. And then the person who comes third has an average of 80. So while there was only a 0.1 difference between first and second, there is an even bigger difference between second and third. And so we say that the distance between scale points is undefined and or not uniform. And when we talk about the distance between scale points being undefined, we're talking particularly about cases where you use scales that people speak, for example, about their level of agreement with statements or their likelihood to engage in a certain behavior. So for example, looking at this scale, you see here that the response options here are very likely, somewhat unlikely, so I'm guessing this is very likely, somewhat likely, somewhat unlikely, very unlikely, right? And then there is don't know, which we could talk about as being a missing value, right? So we see here right away that, for example, when you say somebody is very likely to be asked for ID under the age of 21 when they go to a bar, right? What about the person that says somewhat likely? What is the difference? Can you quantify the difference between somebody who says very likely or somebody who says somewhat likely? You actually can't, because you don't know what that means. And so we say that the distance between those two scale points, we can't even quantify it, right? And so that is definitely something that we need to take note of, okay? So in the ordinal level of measurement, we can say that the distance between scale points, for example, for this variable is undefined. In some instances, there is no uniform difference between those scale points. And so the person who comes first, you only know that they come first. You don't know what the average is, right? Whereas the person who comes second, you don't know, again, who comes second. You don't know what this person's average is. Now, when it comes to the ordinal level of measurement, because the ordinal level of measurement really just performs an ordering function, there are also limitations as to what statistics you can run on ordinal variables. So in terms of descriptive statistics, you can calculate, so for every level of measurement, it should be known that you can do what it is possible to do whatever you were able to do at the lower level of measurement. plus a little bit more. So for example, at nominal, we said we can perform counting functions, so we can get our percentages and our counts and mode, but at ordinal, we can do all of those things. Plus, we can utilize the measure of central tendency called the median, which is the midpoint of the distribution. So you're able to use the median in when you're dealing with ordinal measures. Now, the next level up is called an interval level of measurement, and at the interval level of measurement, numbers begin to take on the characteristics of numbers. However, these numbers have no these scales, interval scales, don't have any meaningful 0 points. What I mean by that is that the 0 does not mean what 0 normally means. Normally, when you see a 0, you know that there is absence of the phenomenon that we are studying. So, for example, if I ask you how much money you have in your pocket, right? You are able to tell me how much you have, or if you don't have none, you say you don't have none, right? Now that is when the 0 is meaningful. However, when 0 is not meaningful, 0 is just part of a scale, and it is possible for the response to be actually less than 0. So, for example, the temperature. I think it is probably one of our best examples of interval level of measurement. The fact of the matter is, in certain parts of the world, it is possible for the temperature to go to 0 degrees Fahrenheit, right? Or negative degrees Fahrenheit, right? Or 0 degrees Celsius or negative degrees. True? Yes. So, what happens when the temperature falls below 0? Does the world stop spinning on its axis? Do things just stop happening? No, that's not what happens. In fact, it's just normal. So 0 is just another number on the scale. So again, 0 in that case does not mean what 0 would normally mean. Now, the ratio level of measurement, the highest level of measurement, 0 is actually now meaningful. And when the 0 is meaningful, the values cannot fall below 0. So for example, how old are you? Like age. The fact of the matter is, age cannot fall below 0, can it? No. The lowest number is 0. There is no negative age. And so we say here that the 0 takes on a meaningful value. So interval measures run from negative infinity to positive infinity, whereas ratio measures run from 0 to positive infinity. In terms of interval and ratio measures, as I noted, SPSS treats them as the same. However, there are minor differences in statistical procedures that you're able to run. However, it is not necessary to actually be able to distinguish between them from a procedural perspective at this level. So I won't necessarily get into it. Now, one thing I should caution about the measure column. You need to know the level of measurement to know what statistical procedures you can run. But you do not want to rely on the measure or level of measurement that has been assigned by the software. The software will try to make a guess, right, as to what the level of measurement is. But it is not always right. So, for example, a variable like age, which we have just discussed, is clearly a ratio measure. The software has said is nominal. That is wrong. So you need to be able to identify, because these are changeable, and you can go in and change the level of measurement. So for example, you look at a variable like academic school year, right? Freshman, sophomore, junior, senior, fifth year plus. Clearly, this is an ordinal measure, right? The person who is freshman is at a lower level than the person who is sophomore is at a lower level than junior. So this is really an ordinal measure. And so do not assume that the level of measurement that has been provided by the software is actually correct, because you're probably going to be wrong. Don't rely on it. You should actually look at the variable itself, look at how the variable is measured in order to know what the level of measurement is. That is always going to be the best way of identifying the level of measurement. All right? Okay. So now that you understand what is going on in the variable view and what is going on in the data view, I am going to take you through some of the menu items in the software. So when you look at, for example, the file menu, you will see that you have new, open, import, data, save as, etc. Some of these things would be familiar to you because some of these menu options are available in any file type. However, when you look at, for example, new, you will note that there are two different types of new files that you can create in the software. And when you click open, also there are different file types that you can open. So just like how you can create a new syntax file and a new data file in the software, you can also open syntax and data files in the software. All right, so let's talk about the different file types. First and foremost is the syntax file, and I'm going to click on the syntax file. As you see here, it is a syntax editor. And syntax, based on your understanding from your basic IT courses, is actually a programming space. So it's a space within which you can actually write commands and then execute them using the run function. And so while the software has the ability that you can actually go through and specify procedures by just following the menu and clicking buttons, one of the things that you're also able to do is to actually write the command yourself and run it. Bearing in mind that when you do the button method, what is happening is that you're specifying the command protocols and the software is actually writing the command for you. And normally, and I'll show you in a bit, but when you are running a procedure and you click, for example, paste, what the software will do is actually paste the command to the syntax editor so you can see the command that will be executed in order to get a particular result that you are looking for. And of course, data file, and that's the data file, and this is what we are working in right now. There's another file type that you're not seeing, and it's called the output file. And this is where the results of your procedures will be presented to you. They're not all in the same. And so you have to actually toggle between or toggle among your data file, your syntax file, and your output file in order to navigate the software. So when you specify a procedure here, you will paste in your syntax, run from the syntax, and then look for the result in your output file. The output file is quite an interesting file because I like to say that it's like a piece of paper. Once you write on the paper, you cannot take it back. Meaning, say for example, you have run a procedure and you realize that there is an error. So for example, the variable has not been clean, your missing values have not been specified. When you go to your data file and you do the cleaning process, which I will show you, it will not reflect on your output file. You have to actually rerun the procedure and generate a new output. Right? So you run frequency distribution, you realize that the data wasn't clean, you clean the data, you need to rerun the frequency distribution in order to actually see the result of the procedure that or of the change that you would have made to your data file. Now, in terms of different file types, all file types are important. But I'd like to say to you guys that of the file types that are most important, your data and syntax files are going to be those files. Why? Once you have your data file and you have your syntax file, you're able to regenerate your output at any given time. So that is one of the reasons why I normally recommend that students, when they finish specifying their command, instead of clicking OK and running the command without seeing what the syntax looks like, I recommend that you paste your syntax to to the syntax file and then run it from the syntax file. This allows you to save the syntax file so that if, for example, you made a mistake, you don't have to go back and re-specify the syntax. Also, if you need to save and come back later, you are able to see the syntax that you ran. It also helps you in terms of learning how to write syntax because you are able to see syntax, copy syntax, modify syntax, and run them. And for students who utilize computers that are likely to crash, timeout, you lose your output sometimes. At least if you have your syntax, you don't have to start all over again because all they have to do is select your syntax and run it again. And you are able to actually get back the output that you had before. So I'll show you how those work because like I said, I definitely do use those files pretty much all the time. And so that's going to be a part of our practice over the duration of this course. So that is your data file, syntax file, and output file. You have some of these other things, renaming, etc. These you would be familiar with. Now in the edit menu, you have functions like inserting a variable, inserting a case, go to variable, go to case, cut, copy, paste, clear variables, clear cases, find options. Then you have view, data, transform, analyze, graphs, utilize, utilities, sorry. Now, in terms of menus that we will use a lot in the software, we'll probably use the file menu very frequently. We will probably use the compute menu. We'll also use the analyze and graphs menu. Okay. Now, this is one of the challenges with this software. It doesn't give you as many graph options. You have scatter plot, histogram, and bar chart, and so those are the charts that we will use. In terms of the edit menu, I will teach you how to insert variables and cases. Remember what we said, a variable is your questions, whereas your cases are your individual person's responses. So hopefully this helps you to get familiar with the SPSS menu. We will be utilizing this menu over the duration of the module. So we'll just practice as we go along and we'll get very used to the different menu items.